Okay, so in this lesson, I am going to show you how to solve a system of equations by linear combination. Or another term that is commonly used is the elimination method. Okay, so I'm going to go ahead and just dive right into an example so you understand what a linear combination method is. So let's suppose we have x plus y is equal to 10. And then we have a second equation, x minus y is equal to 10. The linear combination method is very effective when you have an equation, when you have a set of equations such as this, where eliminating, okay, quote unquote, eliminating a variable makes it very straightforward. And here's what I mean. If we were to add this together, okay, so we're going to add this entire equation together, we're going to get 2x, okay, because x plus x is 2x, okay. Now look what happens to the next variable, y. Y plus negative y gives us nothing. It's eliminated, okay? So then what we're left with is the right side of the equation, and we have 20, because 10 plus 10 is equal to 20. Now the beauty of this is that the y's are gone, so I don't need to write 0 here. Now we can solve for x. And to do that, we divide both sides by 2, or multiply by the reciprocal of 2, which is 1/2, and we get x is equal to 10. Okay, really simple, very quick, very effective. Now that we have x, we can plug x equals 10 into one of these two equations, okay, to solve for y. So let's just pick the first one. Since x is equal to 10, we're going to write 10 plus y is equal to 10. Okay? Solving for y, we move the 10 to the other side of the equation by subtracting 10 from both sides, and we get y is equal to 10 minus 10, or y is equal to 0. Okay? So then our solution is now 10, 0. Okay? So let's test it in the second equation. Okay, we're going to substitute this 10 for x, and we're going to substitute the 0 for y. And the question is, does 10 minus 0 equal 10? The answer is yes, so we know that this answer is valid. So what this tells us is that 10, 0 is the value of x and y, or the coordinate or ordered pair that satisfies both this equation and this equation. Okay, so that example was pretty straightforward. It was easy to eliminate because one equation had one value and then the other equation had exactly the opposite value, and you could essentially eliminate them. But what happens if it's not as obvious? Let's take a look at the next example. Let's say that we have negative 2x plus 6y is equal to 16. And the second equation is negative 4x minus 3y equals 2. Okay? When you look at this, nothing is really straightforward. You're thinking, well, I could do the substitution method, which is true, but the algebra gets a little messy. Okay? I want to use the elimination method, but another way to describe it is the linear combination method, but it's not straightforward. There's nothing I can eliminate that will do it cleanly. So what do we do here? One thing you could do is take this equation this first equation and double it. Okay, why double it? Because when I double this to -4, okay, this becomes the same value but the opposite. Meaning if I multiply this entire equation by -2, we're now going to get a +4 up here. Okay, so let's do that. Let's take this equation and multiply it by -2. Okay, when I do that, okay, we're going to need to distribute, right? This -2, we're going to multiply it by this -2x, and then we're also going to take this -2, multiply it by this x, 6y, positive 6y, and we're also going to take this -2 and multiply it by the 16. Okay, what we get as a result is now 4x minus 12y is equal to -32. Okay, -2 times -2x gives me 4x. -2 times a positive 6y gives me a -12y. And -2 times 16 gives me a -32. Okay, now I'm going to rewrite the second equation right underneath it. Okay, now we can add both equations and look what happens. 4x plus -4x, that's gone. So we can go on to the y. -12y plus -3y is -15y. -32, okay, plus 2 gives me -30. So now we can solve for y by dividing both sides by -15, or multiplying by the reciprocal of -15, which is -1/15. What we end up getting is y is equal to -30 over -15. Okay, a negative divided by a negative becomes a positive number. So then all we're left with is y is equal to 30 over 15, which is equal to 2. Now that we know what y is, we know it's 2, we can plug it back into one of these equations. Okay, so I'm going to plug it into the first one. I'm going to write -2x plus 6 times 2, okay, this 2 goes into this y, and that is equal to 16. So let's simplify. This becomes -2x plus 12 is equal to 16. -2x is equal to 4. Okay, how did I get 4? I've subtracted 12 from both sides because I want to move this 12 over to this side. This is a positive 12, so I have to subtract 12 from this side. And if I subtract 12 from this side, I need to subtract 12 from this side. And then 16 minus 12 gives me 4. Okay? So I skipped a couple steps. Hopefully by now you can see the algebra that's taking place. Then we're going to move this -2 over to this side. Because this is a product, I need to divide both sides by -2. Okay? When we do that, we get x is equal to -2. Okay? Because 4 divided by -2 is -2. So now we have x and we have y. Okay? So our answer is -2, 2. Okay, so let's make sure. We always need to check it. We use the first equation to get our second value, so let's use our final answer and plug it into the second equation just to make sure it's correct. Okay, so the question is, does -4 times -2 minus 3 times 2 equal 2? That's the question. Okay, where did I get this -2? From here. That's my x. And where did I get this to? From here. That's my y. So let's multiply this out. Negative 4 times negative 2 is 8. Minus 3 times 2 is 6. Does that equal 2? 8 minus 6 is 2. And that equals 2. So that checks out. So we know that this is the correct answer. Okay? So hopefully that makes sense. If any of this was not clear, please go back to the beginning of the recording and review it again. Thank you.